Hello, let us learn about Compton effect today. I will start sharing my screen first. Okay, so I am now going to discuss Compton effect with you. So we have already discussed Compton effect briefly. Let me again discuss it here. So when we discussed about Compton effect, we have seen a photon collides with an electron, and then what happens to that? That is what we'll be seeing. So let me go into presentation mode. I will start now. Okay. So what are we going to do today? We are going to discuss Compton effect. Okay. Now look at this. What you see is Compton effect. Beam of X-rays is scattered by a substance of low atomic number. So we are considering a photon as a part of these X-rays. Low atomic number, we are just considering electron. The scattered radiation consists of two components, one having the same wavelength and the other one having a slightly longer wavelength. Now let us see what happens when this phenomena occurs. Okay, I have an electron which is at rest. Now this photon comes in. This photon that is coming in has an energy h nu, and this electron has a rest mass m0 c square. Now, photon, instead of going in the straight line, after the collision, the photon should have actually gone in a straight line. But what do we find? The photon is scattered in one direction, and the electron is scattered in the other direction. So I am assuming photon is scattered at an angle theta to the original direction, and the electron is scattered at an angle phi to the original direction. So the modified energy of photon is h nu dash, and the modified energy of electron is mc square. So we have to now start with law of conservation of energy. So law of conservation of energy. For that, we will need total energy before collision and the total energy after collision. So let us say energy before collision. Okay, let us say energy before collision. Energy before collision. Okay, what will be the energy of photon? Before collision, the energy of photon is h nu, as you can see, and energy of electron before collision we saw here is m0 c square. Now let us take after collision, energy after collision. After collision, the energy of photon, as you can see from here, is h nu dash. H nu dash, and energy of electron is m c square. So from the law of conservation of energy, we know that total energy before collision is equal to total energy after collision. So what do we write? Total energy before collision is the sum of energy of photon and energy of electron. So we have h nu plus m0 c square is equal to h nu dash plus mc square. H nu dash plus mc square. So what do we have here? We have the total energy before collision. We also have the total energy after collision. So this is part one. Then we can move on to the momentum part of it. I am redrawing the diagram. So we have this electron is at rest, and again the photon is coming in the same diagram. I am going to represent the momentum instead of energy here. So the photon is scattered like this and the electron is scattered like this. We just discussed photon is scattered at an angle theta, electron is scattered at an angle phi. Okay. Now, before collision, the momentum of photon is h nu by c. After collision, momentum of photon is h nu dash by c. And after collision, the momentum of electron is mv. Now, the photon should have actually originally traveled in this direction, which is the x direction, but it is scattered along. It is no more traveling along the x direction, rather it is scattered along the xy axis. This is the x-axis. This is the y-axis. Photon is scattered in between the x and y-axis. Similarly, electron is also scattered in between the x and the negative y-axis. Okay, so now we have to develop equation for conservation of momentum. So let us say conservation of momentum, right? So let us start with conservation of momentum. Now, let us say when you are speaking about momentum, momentum is a vector quantity. So you just cannot say it is h nu dash, h nu by c and h nu dash by c after collision, because as I keep repeating, momentum being a vector quantity, direction also matters. Okay, so let us resolve it into two axes, along the x-axis and along the y-axis. Let us say along the x-axis before collision, along the x-axis before collision. So you will have the momentum of photon before collision along x-axis is h nu dash by c, h nu by c. This is the momentum of photon. Now let us consider this electron. Electron is at rest, and you all know momentum P is equal to m into v, mass into velocity. Before collision, this electron is just sitting, which means velocity is zero. Momentum is also zero for the electron before collision. So we shall write for electron before collision, momentum is zero. Now let us take the case of after collision. Again, I repeat, we are only discussing the x-axis. Now your photon is scattered in between the x and y axis, which means I need to express this momentum in terms of the x component, which I am calling it mx, and the y component, which I am calling as my. So what do? Let me complete a triangle. I have a triangle A, B, and C. And this is a right angle triangle subtending an angle theta. This is the adjacent side, and this is the opposite side, which I can call as my, because these two are equal, and h nu dash by c is the hypotenuse. So what can I say? After collision, momentum of photon along x-axis will be represented by mx. I need mx. So what should I do? I should take in triangle ABC, I need the adjacent side. So obviously, you will be speaking about cos theta. Cos theta is equal to adjacent side mx divided by hypotenuse h nu dash by c. H nu dash by c. Or you can say mx is equal to h nu dash by c cos theta. So after collision, momentum of photon is given by h nu dash by c cos theta. Now we need the momentum of electron after collision. For that, let us draw another triangle A, B, D. So again, I need the x component of this triangle A, B, D. So let me say in triangle A, B, D. Now I am concerned about cos phi. Cos phi in this triangle is again adjacent side by hypotenuse. My hypotenuse is mv. So what will I write? Adjacent side is mx and hypotenuse is mv. Or you can write mx is equal to mv cos phi. So momentum of electron is equal to mv cos phi after collision. So now we need to develop an equation for conservation of momentum along x-axis. We shall deal with y-axis later on. So along x-axis, total momentum before collision is the momentum of photon h nu by c plus momentum of electron, which is 0, equal to after collision momentum of photon h nu dash by c cos theta plus momentum of electron, which is mv cos phi. Or I can write this equation as h nu by c is equal to h nu dash by c cos theta plus mv cos phi. This is my equation 2 along x-axis. Now I need to speak along y-axis. So let me again redraw this figure. So I have this electron is at rest. I have a photon coming in, and this is the original direction. And this is how photon is scattered. Every time I tell you, I think you listen you get thorough about it. This is phi, and this is h nu by c. This is h nu dash by c. This is mv. So I have a y-axis as well. So I am completing a triangle A, B, C with theta as the angle. This is my mx. This is my my. And then for electron as well, we have triangle A, B, D, wherein again this is mx and this can be my. Now momentum along y-axis, okay, before collision. Momentum along y-axis before collision. So we need first the momentum of photon. Our photon is moving only along x-axis. Let me recall that momentum is a vector quantity. It is moving only along x-axis, which means it is not moving along y-axis. Along y-axis, the velocity of photon is 0, which means the momentum of photon along y-axis before collision is 0 as well. Anyway, we know momentum of electron before collision also is 0. Now let us take the case of after collision along y-axis, right? So let me take the case of photon first. So now again consider triangle A, B, C. In this triangle, now I need the opposite side. So obviously, when you take this triangle ABC and I need an opposite side, I am going to take sine theta equal to my by hypotenuse h mu dash by c. Or you can write my is equal to h mu dash by c sine theta. So momentum of my photon or our photon is h mu dash by c sine theta. Now let us take the case of electron in triangle A, B, D. A, B, D. I am concerned about now sine phi because I need this opposite side. So sine phi again is equal to opposite side my divided by hypotenuse, which is mv. But I recall momentum is a vector quantity. Here my points upwards. Here my points downwards. Both are in opposite directions, which means obviously this has to be minus my. Or you can write for electron is equal to minus mv sine phi. So let us take the conservation of momentum equation along y-axis. So total momentum before collision is equal to total momentum after collision. So you can obviously write 0 is equal to h nu dash by c sine theta minus mv sine phi. I am going to call it equation 3. Now I am going to bring this equation 2 and 3 to the forefront. Let us see what we can do. Let me write equation 2 first. H nu by c is equal to h nu dash by c cos theta plus mv cos phi. Right? This was my equation 2. And what was my equation 3? 0 is equal to h nu dash by c sine theta minus mv sine phi. This is equation. First, let's square 2 and 3. Let us square equation 2 and equation 3. For that, I need to do some rearrangement. So what will I do for equation 2? H nu by c minus h nu dash by c cos theta is equal to mv cos phi. Right? So what can I do? I can take h as common. Nu minus nu dash cos theta is equal to, I can take the c here, mvc cos phi. Now I shall square this equation. So what do you get? H square. So this the whole square, a minus b the whole square. Nu square minus 2 nu dash cos theta plus nu dash square is equal to m square, b square, c square, cos square phi. Let us call this equation 4. Now let us square equation 3. So equation 3, I can rewrite equation 3 as h nu dash by c sine theta is equal to mv sine phi. Am I right? So again, I can rewrite this equation as h nu dash sine theta is equal to mbc sine phi. Or you can square this equation and write as h square nu dash square sine square theta is equal to m square b square c square sine square phi. This is my equation 5. So what should I do now? Add 4 and 5. Let me write 4. H square mu square minus 2 mu dash cos theta plus mu dash square is what we have in 4 here, right? So, okay, this whole thing is equal to m square b square c square cos square phi. This is my equation 4 minus h square nu dash square sine square theta is equal to m square b square c square sine square phi. So I have just written 4 minus 5. So if you look at the left hand side, we can see h square is common. Mu square minus 2 mu dash cos theta. For this I have a cos square theta here, sorry. 2 mu dash cos theta plus mu dash square cos square theta, and I can club it here, plus mu dash square sine square theta is my left hand side, right? Now my right hand side will be m square c square v square cos square phi plus sine square phi. So what will I have here? I can again rewrite this as h square mu square minus 2 mu dash cos theta plus mu dash square cos square theta plus sine square theta, because both these terms have mu dash square, right? And then we have m square c square v square, because obviously cos square phi plus sine square phi is equal to 1. So now again I can rewrite this equation as mu square minus 2 mu dash cos theta plus mu dash square is equal to m square c square v square. I shall call it equation 6. Why am I doing this? Here I have cos square theta plus sine square theta, that is also equal to 1. So you have this equation 6. Now let me call this fellow equation 1, which says h nu plus m naught c square is equal to h nu dash plus mc square. This is my equation 1. So I shall rewrite it. H nu plus m naught c square is equal to h nu dash plus mc square. I will rewrite this equation as h, I'll take this side, nu minus nu dash plus m naught c square is equal to mc square. Now let us square this equation. Let us square this equation. So when you square this equation, actually this the whole square, this the whole square, a plus b the whole square. So what will you have? H square nu minus nu dash the whole square plus 2h nu minus nu dash m naught c square 2ab, okay, plus m naught square c power 4 is equal to m square c power 4. Now what we do is we have to again square this. H square nu square minus 2 nu dash plus nu dash square plus 2h nu minus nu dash m naught c square plus m naught square c power 4 is equal to m square c square. This I shall call equation 7. Now go in for 7 minus 6. So let me say your 7 is h square nu square minus 2 nu dash plus nu dash square. So shall we combine the h square terms together? So what do I have here? I have in 6 nu square minus 2 nu dash cos theta plus nu dash square. So what will I do? Minus nu square plus 2 nu dash cos theta minus nu dash square. So see, I have subtracted 6 from 7. So what do I have here? I have nu square minus 2 nu dash cos theta plus nu dash square. This will be minus, this will be plus, this will be minus. That is what I have written here. Minus plus minus. Then let me write this term. 2h nu minus nu dash. I am writing only the left hand side, okay? M naught c square plus m naught square c power 4 is equal to m square c power 4 minus m square c square v square. M square c power 4 is in equation 7. M square c square v square is in the right hand side of equation 6. Now let us come here. Nu square and nu square, they get cancelled. Nu dash square also, they get cancelled. So what can I write? H square 2 nu dash plus 2 nu dash cos theta plus 2h nu minus nu dash plus m naught, sorry, 2h nu minus nu dash m naught c square plus m naught square c power 4 is equal to m square c square is common, and you can write c square minus c square. And I'm just making a tiny modification in this equation, wherein I am writing, I am taking, you have this negative sign here. So 2 nu dash is common for both. I am taking minus 2 nu dash outside. So I have minus 2 nu dash h square 1 minus cos theta. Why? I have taken the negative sign outside. So this becomes plus, this becomes minus. The other terms remain as they are. Nu minus nu dash m naught c square plus m naught square c power 4 is equal to m square c square minus v square. Let me call this equation H. Now we have a relativistic mass equation given by m is equal to m naught root of 1 minus v square by c square. Now I am going to square this. So what can I write? M square is equal to m naught square divided by c square minus v square by c square. Or what can you write this as? You can write this as m square c square minus v square is equal to m naught square c square. Rearranging this. So now look at this equation and look at the right hand side of this equation. I have m square c square into c square minus v square. Here I have m square into c square minus v square. So the difference is a c square. So let us multiply by c square. So what will you get? M square c square minus v square is equal to m naught square c power 4. I am multiplying the entire equation by c square. So this would be our equation 9. Now compare 8 and 9. Let's go back to 8. 8 m square c square minus v square is on the right hand side, and 9 m square c square minus v square is on the left hand side, which means I can equate both. So I'm going to write equation 8 again. So minus 2 nu prime h square. So let me go here. Minus 2h nu prime 1 minus cos theta plus, so what is 8? Minus h square. 2h nu minus nu prime m naught c square. Okay. 2h nu minus nu prime nu dash, sorry, m naught c square. And what does 8 say again? 2h nu minus nu dash m naught c square plus m naught square c power 4 plus m naught square c power 4 is 8 is equal to m naught square c power 4 of 9. So m naught square c power 4. So obviously when you take it this side, these two terms will go. So these two terms will anyway get cancelled. So I have 2h square nu dash 1 minus cos theta plus 2h nu minus nu dash m naught c square equal to 0. So what am I doing? 2h nu minus nu dash m naught c square is equal to, I'm taking this side, 2h square nu dash 1 minus cos theta. 2 I can cancel off, h I can square cancel off it, h square. So I am going to club all the new terms together and take all the other terms to one side. So I have nu minus nu dash by nu dash is equal to, I have a h, m naught c square comes to the denominator, m naught c square into 1 minus cos theta. Again, I rewrite this as nu by nu dash minus nu dash by nu dash is equal to h by m naught c square into 1 minus cos theta. So nu will get cancelled, nu dash will get cancelled. I have 1 by nu dash minus 1 by nu is equal to h by m naught c square 1 minus cos theta. Now I want to find Compton wavelength, and you know nu is equal to c by lambda, or you can say 1 by nu is equal to lambda by c. So what do I write here? I have a nu dash here. So lambda dash by c minus lambda by c is equal to h by m naught c square into 1 minus cos theta, or since c will get cancelled, what do I have here? Lambda dash minus lambda is equal to h by m naught c into 1 minus cos theta. This is my this will be my Compton shift, equation of Compton shift. Okay, so this is Compton shift derivation, which you can also write as d lambda is equal to h by m naught c into 1 minus cos theta. So this would be Compton shift, right? D lambda is equal to h by m naught c, 1 minus cos theta. So which means this is lambda dash minus lambda. The change in wavelength depends on this right hand side equation. So look at this, h naught is, h is a constant. Sorry, this is not h naught, it is h. H is a constant, m naught is a constant, c is a constant. You know, m naught is the mass of the electron, c is the velocity of light, h is Planck's constant, they are all constant. And the only variable is theta. What is theta? Theta was the angle of scattering of the photon. So the shift in wavelength depends only on the angle of scattering of the photon, is what is given by Compton effect. Let's again meet for another derivation shortly, right? Let me just finish it.